Welcome back to Illuminate. So we were discussing type 1 and type 2 error. So now that we are clear with type 1 and type 2 error, what they are, now let's understand how these errors can be mitigated or how we can take control over these. So here let us understand first statistically what is significant and what is not significant. So we had earlier drawn a confusion matrix. We'll continue with the same case study and same confusion matrix so that we are all on the same page in understanding this concept. We had a predicted, that means what are we saying about the data. So we were saying two things. One is null and alternate hypothesis, that is the null hypothesis was no change in temperature, and the alternate hypothesis was there is at least 2 degrees Celsius increase in global temperatures. So this was our claim. So this part is our claim. So this is important. So this claim is what we are predicting. So predicted, positive, negative, again positive, negative. Let's go with a different color. Yeah, this is positive, this is positive we are predicting, this is negative we are predicting, this is negative we are predicting. Now if I say this is true, this is false, this is again false, this is again true. So this part and this part. So here we had type 1 error, just a quick refresher. Here we had a type 2 error. We'll have to go back to the previous session to understand type 1 and type 2 error clearly, so that this session will be more useful for all folks. So this is actual condition, this part is actual condition, this part is what we are claiming or predicting. Claiming and then we are predicting it. Now what we want to know is, okay, we had taken this temperature as an example, global warming as an example, and we are saying, let us assume, okay, that the mean temperature is say around 30 degrees Celsius. Let this be the mean temperature, just assuming it, okay. So mu or mean temperature is what is, mu naught is what your population mean temperature, that is historically measured, that is 30 degrees Celsius, whatever. So now let me draw this case to understand how the errors can be understood, right? So let this be the 30 degree mark, 30 degrees Celsius mark. So I'm just plotting a normal distribution around this 30 degrees Celsius. So this is the mean temperatures. So in a normal distribution, everything, mean, median and mode, everything is here. So we have it here, 30 degrees Celsius. This is your mu naught. Now let me switch color. Now let us also assume the standard deviation, that is population standard deviation, maybe as say 2 degrees Celsius. Okay, so the variation is say 2 degrees Celsius. Now if you go back to your statistics and understand, we have like one standard deviation, that is 30. If I say this is 2 mark, say 2, this distance is 2, this distance is 2 on the positive side, this on negative side, and this on positive side, plus 2, minus 2. So this is what one standard deviation on both sides, okay. And this is again plus 1 standard deviation, that is 2 standard deviation, 1 plus 1, and 2 standard deviation on the other side, okay. So 2 standard deviations, this area under the curve. So this area, let me shade this. So this area basically, which is in between this plus or minus 2 standard deviation, this is basically nothing but 95% of area that we have covered, okay. So this is 95% of area that we have covered. The remaining that we have on either side, this side and here, it's nothing but combined it's 5%, but if you go on the left hand side, it's 2.5%, okay, 0.025, and again on the right hand side it's 2.5%. So this is standard. So we have 2.5% of data in the left hand side and 2.5% of data on the right hand side. So this is what we have in a normal distributed curve. So in this we have 30 as a mean temperature. Now let's understand this with respect to what we have here in type 1 and type 2 error. Now this drawing is based on null hypothesis. So what is this? This is nothing but our null hypothesis. This is based on your null. So whatever comes under this area, green area here, whatever comes under this area is what we accept or we fail to reject, basically accept, or you can understand as fail to reject null hypothesis H0. We accept H0. This is a region where we accept H0. That means average temperature is 30 degrees Celsius and the temperature is within this 95%, which makes us to say that the temperature has not increased by more than 2 degrees Celsius. Okay. So if it comes here or if it comes here, it has either increased on the right hand side or it has either decreased, that the temperature has decreased by more than 2 degrees Celsius. That is what will happen. Okay. So in our case, if it falls in this 95% area under this curve, that means we fail to reject the null hypothesis. That is what will happen. Okay. So what is type 1 error? What was that? Type 1 error in terms of null hypothesis? We reject null hypothesis, it's not reject null, when it is not correct, right? We rejected null hypothesis when it is not correct. That was your type 1 error, and let's write it null hypothesis based here as well. So type 2 error, we fail to reject null hypothesis when it is not, so again we fail to reject null hypothesis here when it is not correct. So these were the two errors that we are making. Now to add to context, let's take the sample or the actual alternate hypothesis mean as well. Okay, with a different color, let me take somewhere here, it might be more than 30 or something like that, and draw a distribution really around this, a normal distribution around this. So how it will be, we have say the 95% of this coming around this place. Okay, this is a area for this particular mu 1, or we can say this as H not alternate hypothesis, alternate hypothesis. So this area, now let's depict below, and then just write it here. This part, basically this part is nothing but your alpha. You have decided your alpha to be 0.05, nothing but 5%. So 95% in this area and 5% you are kind of deciding on your alpha. Assuming again there is a concept of one tail test and two tail test here. So if you split on both sides, it will be 2.5%. But then if you are only focusing on the right tail, right hand side, so it will be 5% on the right hand side. If you are focusing only on the left hand side, the temperature is reduced, that means left hand side, then it will be 5% on the left hand side. So I'm just keeping this as 0.05 alpha. That means I am checking for 95% confidence and alpha is my 5%. I've decided alpha as 5%. So there are 5% chance. So this alpha is nothing but your 5%. And what is alpha? It's nothing but your, I'll write here as well, alpha is equal to 0.05 or 5%. This is nothing but your type 1 error. So this is your type 1. That means, now again read this part. Reject null hypothesis. Okay, you are measuring, you have taken some data of temperature data of this year and you compare it with previous year, and what happens is you reject null hypothesis. That means your point of measurement of mean temperature falls in this area, basically this area falls in this particular area. That means it's outside your 30 degrees Celsius 95%, it falls in this area, and you say you reject null hypothesis. But actually it was not to be rejected. Actually the temperature didn't change much. Means it was within this 95% range, but then your observation or your data collection or your result yielded a view that it has changed more than 2 degrees. So you rejected null hypothesis when it should have been not rejected. It should have been placed here, but you actually rejected it. So that's where you are making type 1 error. So what is the chances of making type 1 error? There are 5% chance. So 95% is your confidence level. Okay, 1 minus alpha is what? your confidence level is equal to your confidence level. Alpha is what you're deciding is 5%. Okay, so 95% confidence and 5% alpha level. You can take this as 2.5%. So your confidence will go up to 97.5%. It all depends on the case that you are dealing with. You want to be strict in constricting or reducing your false positives, then you will have to keep your confidence level high. So you'll have to pick a lower alpha value based on the test. If you are checking something medical, or if you're checking, say, a spam filtering case where positive, as we have seen in the last video, you can check out for that video as well in the classification. There we have discussed where, in which kind of situations false positive is important. So in those cases, if you want to prove or if you want to reduce the false positive, that is a priority, then you will have to keep a high alpha value, a low alpha value, so that your confidence level will be 1 minus alpha, that is very high. So what is this region basically? This region is nothing but your true negative, this true negative. So this is nothing but your 1 minus alpha. How is it coming as true negative? Because we are talking in context of now null hypothesis. So this is what positive is, what we are claiming it to increase by 2 degrees Celsius. So but this is what, if this comes here, that means we are not saying that it has increased by 2%. There is no change, right? There is no change is what is not our claim. There is no change is not our claim. So that is negative. But this 95% is correct. So true. So true negative part. So if it falls here and we are correctly saying that it falls here, yeah, there is no change in temperature, negative, okay, and that is correct. What we are saying is correct. That means 2 negative. So this is our confidence level, 1 minus alpha. So alpha is 0.05 and 1 minus alpha is your confidence level, true negative. Okay. Now let's move to false negative and true positive. Okay, now we'll discuss for type 2 error. So we failed to reject null hypothesis. That means we have accepted the claim saying that it has not increased by 2 degrees Celsius. Sorry. So failed to reject null hypothesis. That means we accept null hypothesis. There is no change. There is no change. Okay. Now if you see the tail of the alternate hypothesis coming over this side, right? So here, post this point from here to here, like this. If I kind of shade this area, the 5% area of the alternate hypothesis here on the other side, right? Here we have, this was your alpha. Now similarly, this white shaded part over here is nothing but your beta. Now pay attention, beta. Now beta is nothing but your type 2 error. So beta is nothing but your type 2 error. So what are we saying in type 2 error? We are accepting null hypothesis, right? See this zone, let us take some red color, see this zone. This zone is what? 95 confidence of null hypothesis. That means we have accepted null hypothesis, right? So we are failing to reject null hypothesis. We are accepting the null hypothesis when it should have been what? It should have been alternative hypothesis. When the temperature has actually increased and we are saying we accepted the null hypothesis, that means we are making there are chances, probability of making an error beta, this small area beta, this is a probability where we will make the type 2 error. So that's how it is coming as type 2 error beta. Then what is true positive? Very easy again. Positive is our claim. The claim is that the temperature has increased by 2 degrees Celsius, right? So let's switch back to white. So this is our claim, that the alternate hypothesis, that there is a temperature increase in 2 degrees Celsius. Our claim is, this is what is our claim, that is positive. We are saying, and we are correct in saying that, true positive, and we are correct in saying that, true positive. That means this part of it is beta, that means this part of it is 1 minus beta. So this part is true positive is 1 minus beta. This is nothing but 1 minus beta is nothing but your power of test, your power. So what is the power of your test? Is 1 minus beta. So these are the 4 concepts. This is what is type 1 error and type 2 error in context of a global warming where there is an increase in temperature. So you'll have to pay keen attention and then listen this maybe 1 or 2 times to understand the concept. I think I made it clear with the case study. So in continuation to this, in the next session, we will cover what is important to decide the sample size for doing any kind of a hypothesis testing, to decide on false positive, false negative, whatever, where it is applicable, and how do we decide that whether our test sample should be this much. Thank you for listening, awaiting your comments and feedbacks to improve further. Please support the channel.